Hello guys, welcome to Sleepumentary. Tonight we are going to take a step far, far beyond our daily lives out into the vastness of the cosmos, and then slowly, gently bring our focus back to the one fragile place we call home. Imagine for a moment that you could look at the universe not as a human standing on Earth, but as an outside visitor hovering somewhere beyond the stars. From that vantage, the universe stretches in every direction, infinite and unrelenting. You would see spiral galaxies, magnificent wheels of light slowly turning in the black ocean of space. You would witness stars being born in clouds of fire and dust, while others collapse into silence-ending cycles that spanned billions of years. Worlds would circle these stars, rocky, gaseous, frozen, scorched, each one a story of chemistry and physics written in orbits and atmospheres. Some of those planets would be monstrous. A few rain sulfuric acid droplets that would burn through metal in seconds. Others hide crushing pressure beneath layers of dense atmosphere strong enough to flatten a human body instantly. Some worlds are so hot that metals would boil into vapor, while others are colder than anything we can truly imagine, where even the air itself would crystallize into ice. And yet in the middle of this vast, dangerous and chaotic expanse, you would find something so improbable, it almost feels impossible. A tiny world orbiting on a rather ordinary yellow star tucked into the quiet suburbs of a galaxy that looks much like any other. A world no larger than a grain of sand against the backdrop of eternity. And yet it is alive. Not just alive in the sense that organisms grow here, but alive in a deeper sense. It breathes, it renews itself. It shields and balances. Carl Sagan once called it the pale blue dot, and from a cosmic distance that's exactly what it is. But if you look closer, you realize that this dot is anything but ordinary. It is an island of astonishing stability and improbable harmony. Its oceans shift and sigh like the lungs of a great organism. Its forests reach upward, pulling carbon from the air, releasing oxygen in return like a heartbeat in green. Deep beneath its crust, molten currents stir recycling rock and gas to keep the surface fertile and temperate. A magnetic shield wraps around it like invisible armor, fending off the solar winds that would strip its skin bare. The atmosphere, that fragile veil of gases, is not too thick, not too thin, but precisely tuned to protect and to nourish. It traps just enough warmth to keep the oceans liquid, but not so much as to suffocate them. It filters deadly radiation while letting in the gentle glow of the sun. And that sun itself is the right kind of star, not too large to burn out in a blink of cosmic time, not too small to lock its planets in tidal prisons, but balanced, steady, long-lived, generous with its light. When you consider all of this together, the distance to the sun, the size of the moon, the tilt of the earth, the invisible shield, the composition of the atmosphere, you begin to see how every factor rests on the knife's edge of improbability. If even one of these had been slightly different, life as we know it could never have emerged. This is not a religious claim, nor a call to see design, where there may only be chance. It is rather an invitation to marvel, to pause, to let wonder soften your breathing. For the sheer odds of this world existing as it does are so small that the only reasonable response is awe. Think of it this way: we live inside a cosmic puzzle, and somehow every piece is aligned so precisely that it holds together a picture of life, and we are part of that picture. Every heartbeat, every thought in your mind as you lie here tonight is sustained by conditions that are unimaginably rare. So before we journey deeper into this exploration of Earth's improbable perfection, take a moment to reflect on where you are. Not in your room, not even on your street or in your city. You're on a fragile blue sphere adrift in a sea of fire and ice, impossibility and void. And yet you are safe here, alive, breathing, listening. That is extraordinary. And so tonight we begin our journey not to find answers, but to dwell in questions, to hold wonder in our hands and let it ease us into rest. For this is not only a story of science and history, it is a story of home. Before we continue, if this tale keeps you company tonight, leave a like and subscribe, only if it truly feels natural. And now softly tell me, where are you listening from and what hour has the night brought you? If you let your mind linger for a moment on Earth, this pale blue dot suspended in blackness, you begin to notice that its miracle is not merely that life exists here, but that life thrives in such astonishing abundance. Forests that stretch for miles, rivers that carve valleys, birds that weave through the sky, and entire civilizations that rise and fall across its surface. This is not the random chaos of survival clinging desperately to the edge. It is the flourishing of something intricately balanced. Scientists often call this balance fine-tuning, and though the phrase sounds almost mechanical, the reality it describes is something almost poetic. Imagine a symphony where every instrument must play its part with absolute precision. If the violin was slightly off-key, the harmony would collapse. If the drum struck too soon, the rhythm would stumble. Our planet is that symphony, and the instruments are countless distance tilt rotation atmosphere oceans, magnetic fields. Consider just the tilt of Earth's axis, 23.5 degrees. Shift it only a few degrees and winters would deepen into brutal world-freezing seasons, or summers would swell into scorching ages that stripped continents bare. Adjust the rotation of the planet so a day lasted only 12 hours, or stretched to 50, and winds would become relentless tempests or deserts of heat and cold. Even the balance of oxygen in our air, now a calm 21%, could doom us with just a minor change. Too much and wildfires would rage without end. Too little and the metabolism of complex animals would collapse. And yet here we are. Every single parameter sits within a narrow window that allows life not only to survive, but to diversify, to explore, to wonder. This doesn't mean Earth is perfect in the sense of being free from catastrophe. Far from it. The history of our world is filled with mass extinctions, volcanic winters and ice ages that nearly extinguished entire lineages. But even within those upheavals, the underlying conditions remained within the razor-thin margins that permitted recovery. Life could bend but not break, rebuild but not vanish entirely. What is remarkable and what humbles scientists and philosophers alike is how improbable this is. If you imagine rolling cosmic dice, the odds that all of these factors would fall into the exact arrangement we enjoy today seem impossibly small. Mars only half again as far from the Sun as Earth lies barren and frozen, stripped of its atmosphere. Venus just a little closer as a choking greenhouse inferno. Both are worlds that could have been cousins, but instead became warnings. And yet Earth against those same odds sustains rain and rivers, forests and coral reefs, whales and sparrows us. This improbability has led to centuries of reflection. Some call it coincidence. Others see deeper laws of nature we have not yet uncovered. But what matters here as you rest and listen is not which explanation you prefer. It is the sense of wonder that the question itself awakens. To notice that we are balanced on a knife's edge, and yet we are here alive, breathing, conscious. It is easy in daily life to forget this. Bills to pay, errands to run, the endless hum of human concerns can shrink our world to the size of a desk or a doorway. But when you step back, when you remember that life only exists because a billion improbable conditions aligned, the ordinary feels transformed. Every sip of water, every breath of air, every sunrise is the continuation of a cosmic miracle. And that is the thread we will follow through this journey. Not argument, not doctrine, but awe. Awe at how countless factors stitch themselves into the fragile tapestry we call home. Awe at how precarious it all is and yet how enduring. Awe at how this little planet against all odds became a cradle of life. Tonight, as you sink deeper into stillness, you are not just lying in bed. You are resting in a cosmos that by every rational calculation should have been empty, and yet here you are. Among astronomers, there's a phrase that sounds almost like something from a fairy tale, the Goldilocks zone. Not too hot, not too cold, just right. It's the region around a star where liquid water can exist on a planet's surface, and since water is the medium for nearly all the chemistry of life, it's the single most important real estate in the cosmos. Earth, almost miraculously, sits right in the heart of this zone. At an average of 50 million kilometers from the Sun, one astronomical unit, it receives just the right amount of energy. If we were only 5% closer, oceans would boil away into steam, leaving behind a desiccated husk. If we were only 5% farther, those same oceans would freeze solid, locking the planet into a glacial prison. That razor-thin margin is the difference between a flourishing biosphere and a silent, lifeless rock. You can picture this with a simple metaphor. Imagine our solar system shrunk to the size of a football field. The Sun would be a beach ball placed at one goal line. The Goldilocks zone would be a strip only a few centimeters wide, somewhere near midfield. And Earth, it would be a single grain of dust floating precisely in the center of that strip. Our entire existence depends on landing in that tiny slice of cosmic geography. To see how delicate this is, look at our nearest neighbors. Venus, just 30% closer to the Sun than Earth, endures surface temperatures of 460 degrees hot enough to melt lead. Its atmosphere is a choking cloak of carbon dioxide with pressure so intense it would crush a human in seconds. Mars, 50% farther from the Sun, is the opposite extreme. A frozen desert where air is thin as whispers and winter nights plunge to -90 degrees Celsius. In cosmic terms, both are only slight adjustments away from our orbit. Yet those small shifts mark the gulf between a world of storms and oceans and worlds of silence and dust. And so we live in this delicate balance, the perfect distance for liquid water. Water that flows in rivers, gathers in lakes, churns in oceans, evaporates into clouds and rains again onto the soil. This cycling of water is not just a pleasant backdrop to life, it is life. Every cell in your body, every forest on Earth, every fish in the sea owes its existence to this balance of distance. In the last 30 years, astronomers have discovered thousands of planets circling other stars. They call them exoplanets, and among them only a small handful lie in their stars' habitable zones. Even fewer are rocky worlds like ours. Fewer still may have the atmospheric stability to keep water liquid. Each discovery is thrilling, but what stands out is how rare our situation is. Planets are everywhere, yes, but planets like Earth. Planets where the balance tips toward life, they are precious needles in a galactic haystack. And here is a humbling truth. Even those exoplanets that sit in their own just right zones are still mysteries to us. We cannot yet see their rivers or taste their air. For now, Earth remains the only place we know with certainty that water flows freely and life fills the skies and seas. So the next time you watch sunlight glittering on a lake or see rain tapping against a window, remember these ordinary moments are only possible because our world orbits in exactly the right place to be. Out of infinite distances, Earth found the one where warmth and water can dance together, and in that dance life was born. Now that we've seen how Earth sits in the narrowband of the Sun's habitable zone, we need to look at another quiet, almost invisible gift, the stability of our orbit. Earth does not simply circle the Sun in some wild, elongated loop. Instead, our path is nearly circular with an eccentricity of just 0.017. To put that in perspective, it means our distance from the Sun varies by less than 2% across the entire year. That tiny detail may not sound dramatic, but it is the very foundation of climate stability. Imagine if Earth's orbit were stretched into a long ellipse. There would be times in the year when we were far closer to the Sun, sweltering under far greater solar energy, and other times when we drifted far away, wrapped in planetary winter. Seasons would not just be gentle variations, they would become brutal extremes. Ecosystems would collapse under such instability. Plants would struggle to time their growth cycles. Animal migrations would be thrown into chaos, and complex life might never have found the steady ground it needed to flourish. If you're still journeying with me, write the number 1 in the comments, so I know the story still has you. Other planets in our solar system demonstrate this contrast. Mercury, closest to the Sun, follows a path with a much higher eccentricity. It plunges from blistering heat to icy cold in dramatic swings that make stable climates impossible. Even Mars, our cold red neighbour with an eccentricity about 5 times greater than Earth's, sees noticeable variations in solar energy. Its thin atmosphere cannot buffer the changes, and the result is a world defined by instability, dust storms the size of continents and temperatures that swing wildly. Earth's gentle, almost perfect circle is different. Because our distance hardly changes, the rhythm of our seasons is shaped primarily by the tilt of our axis, not by how far we wander from the Sun. This consistency is why life could anchor itself in place, why forests could take root for centuries, why reefs could build themselves over millennia, and why human civilizations thousands of years later could rely on relatively predictable cycles of warmth and cold, wet and dry. Think of it as a clock. Life depends on knowing the time, not the hours and minutes we keep on our walls, but the deep planetary time of sunrise and sunset, of solstice and equinox. A wildly elliptical orbit would be like a clock that sometimes runs too fast, sometimes too slow, never predictable. Earth's nearly circular path, however, is like the slow, steady tick of a master-crafted timepiece. It keeps the climate in tune long enough for complexity to unfold. When you stand outside on a summer's evening and feel the warmth fading into night, or when you notice the crisp bite of autumn arriving right on schedule, you're experiencing the gift of that orbit. Without it, every year would be a gamble, every harvest a desperate chance. Instead, life has been granted something astonishing: continuity. And it is this continuity, this quiet, dependable balance that allowed fragile molecules to become cells, cells to become creatures, creatures to become us. Without orbital stability, there is no stable Earth. And without stable Earth, there is no story to tell. Sometimes when you step back and look at all of these fragile alignments, the distance to the Sun, the circular orbit, the tilt of the axis, the balance of atmosphere, it feels less like science and more like chance. as if Earth reached into a bowl of cosmic tickets and somehow pulled out the one winning number. Astronomers today call it the cosmic lottery, and the more we learn about other worlds, the more extraordinary our luck appears. In the last 3 decades, modern telescopes have revealed more than 5,000 confirmed exoplanets orbiting distant stars. Each new discovery is a reminder that planets are not rare at all. They are everywhere, gas giants that hug their stars in blistering infernos, frozen spheres orbiting in darkness, rocky planets locked in tidal embrace showing one face forever to their sun. The galaxy is filled with worlds. And yet almost every single one we've found is inhospitable. Too hot, too cold, too storm-tossed, too irradiated, too barren. Even the few that orbit within their star's habitable zones may be wrapped in poisonous air or stripped bare by stellar flares. From all those thousands, only a handful are possible candidates for something resembling Earth, and even those remain uncertain. It is in this context that Earth begins to look less like an ordinary rock and more like a shimmering anomaly, a tiny exception in a galaxy that otherwise seems hostile to complexity. It is like walking into a desert of endless dunes and finding a single lush oasis, a place with shade fruit, water, and songbirds standing alone against the horizon. And so the metaphor of the lottery holds. We did not design the winning ticket, we simply live upon it. Earth carries the numbers that allow liquid water, stable climate, breathable air, and protective shields. And as improbable as that seems, it is the foundation of every story you have ever heard, every life you have ever known, every breath you are taking right now. Think about that. The odds stacked against us are staggering. Out of billions of planets in our galaxy, out of trillions across the universe, this fragile blue dot holds you listening in the quiet of your room tonight. This doesn't have to lead to conclusions about purpose or destiny. It can simply lead to wonder, to a soft, reverent awe at the improbability of being here at all. For when you look up at the night sky at those countless points of light, it is humbling to realize that you are not just looking outward. You are also, in a sense, looking inward into the extraordinary lottery that made you possible. Earth won. And because it did, you are here breathing alive, conscious enough to notice. That awareness itself may be the rarest prize of all. When we think of habitability, we usually picture the warmth of sunlight on Earth's oceans, or the gentle pull of the moon shaping the tides. But there is another scale, far larger, that also governs whether life can flourish, the scale of the galaxy itself. Just as stars have a Goldilocks zone, galaxies do too. Astronomers call it the galactic habitable zone. It is not a place marked on a map, but a region where the conditions are stable enough and the ingredients plentiful enough for planets like Earth to exist and sustain life. Move too close to the galactic center and danger multiplies. Their stars crowd together in violent density. Supernovae erupt with terrifying frequency, bathing their neighborhoods in radiation lethal to fragile molecules. Pulsars whip out beams of high-energy particles. Most ominous of all, a supermassive black hole lurks at the very heart of the Milky Way Sagittarius A. Its gravitational violence shapes everything nearby, while its outbursts of energy would sterilize worlds unlucky enough to orbit close. Now drift too far outward toward the edge of the galaxy, and the opposite problem emerges. Out there, stars are fewer and poorer in metals, the heavy elements forged in earlier generations of stars. Without those elements, there are no rocky planets, no iron cores to generate magnetic shields, no complex chemistry to seed oceans or atmospheres. A planet born in the galactic suburbs might be stable but barren. And then there is Earth suspended in a kind of cosmic middle ground. We orbit our sun about 26,000 light-years from the galactic center, a position astronomers consider almost ideal. We are far enough away from the dangerous chaos of the core, yet close enough to the dense spiral arms to inherit the heavy elements scattered by countless ancient stars. It is as if Earth chose an apartment in the quiet neighborhood of the galaxy where the noise is distant, but the resources are still abundant. Our position grants us more than just safety. It gives us perspective. From here, when the night is clear, we can look inward and see the great river of stars, the Milky Way, arching across the sky. It is both a reminder of the vastness we are part of, and a quiet reassurance that we live in a place just removed enough from danger to allow life the patience it needs to unfold. This placement too is part of the improbability. We are not only in the right orbit around the right star, but in the right orbit around the right part of the galaxy. Our survival is written not only in planetary parameters, but in galactic geography. When you gaze up at the Milky Way stretching like a pale cloud across the darkness, remember it is not only a sight of beauty. It is the landscape of our survival, and our improbable home lies precisely where it must balance between peril and scarcity. At the heart of it all, our world orbits an ordinary-looking star, a G-type main sequence star glowing quietly in the suburbs of the Milky Way. Astronomers classify it with technical precision, but what those letters and numbers really mean is this. Our sun is neither too big nor too small. It is steady, stable, and remarkably long-lived. If the sun were much larger, say a blue giant, it would blaze with violent brilliance, burning through its fuel in only a few million years. Life would never have the chance to take root. The window of time would close long before even the simplest organisms could evolve. If it were much smaller, a red dwarf, the most common kind of star in the galaxy planets in the habitable zone, would orbit so close that they'd become tidally locked. One face scorched in perpetual day, the other frozen in endless night. Worse still, many red dwarfs are unstable, flaring unpredictably and bombarding their planets with radiation. But our sun is balanced. At about 4.6 billion years old, it is middle-aged in stellar terms and will shine stably for billions more. This long span of reliable warmth is what allowed life on Earth to begin stumble, nearly vanish, recover, and eventually flourish into ecosystems complex enough to sustain us. In a cosmos where most stars are inhospitable for one reason or another, ours is a rare gift. Yet beyond astronomy, the sun has always been more than a ball of plasma to humanity. For ancient civilizations, it was the pulse of existence itself. The Egyptians revered Ra, the sun god, whose daily journey across the sky symbolized renewal and order. The Aztecs offered rituals to keep the sun rising, believing that their sacrifices sustained the cosmos. In the Andean highlands, the Inca worshipped Inti, honoring him with golden temples that gleamed like miniature suns. Everywhere across continents and centuries, the sun became a symbol of survival and time. Farmers planted by its cycles, priests measured solstices to mark calendars, poets described its rising as rebirth, its setting as death. Even today we live by its rhythm, waking with its light resting in its absence. From a scientific view, we can say the sun is a sphere of hydrogen and helium fusing into heavier elements, releasing photons that scatter and warm our world. But that description, however accurate, leaves something out. It misses the awe of sunrise after a long night, or the comfort of feeling sunlight on your face after winter's chill. It misses the truth that without this particular kind of star, steady, stable, perfectly balanced, there would be no oceans to sparkle, no trees to grow, no minds to wonder. The sun is not unique in the universe, but it is unique to us. It is the exact star we needed. And across the span of human history, we have known in myth or in science that without it there would be no story at all. The sun is not the biggest, the brightest, or the most exotic star in the sky, but in many ways it is the perfect star for life. Its quiet balance, its remarkable stability, and its generous lifespan have given Earth something rare in the cosmos time. Time for oceans to form, for continents to shift, for single cells to experiment, fail and flourish into forests, whales, and human beings who can sit back and reflect on it all. Our sun has been burning steadily for about 6 billion years, and it is only halfway through its main sequence life. Astronomers estimate it will continue to shine with dependable stability for another 5 billion years before swelling into a red giant. That means Earth has been granted a multi-billion-year window of relative calm, a stretch of time vast enough for evolution's long, uncertain experiments to play out. This longevity is not guaranteed with all stars. Massive blue stars live and die, quickly exploding as supernovae in only a few million years. Small red dwarfs live far longer, but their violent flares can strip planets of atmospheres, sterilizing any fragile beginnings. The sun, by contrast, sits in a sweet spot large enough to fuel complexity, small enough to avoid chaos. Of course, it's not always entirely calm. From time to time, the sun reminds us of its raw power. In 1859, the world experienced the Carrington event, the most powerful solar storm ever recorded. Telegraph lines sparked with fire operators were shocked, and auroras flared so brightly they lit up the night sky as far south as the Caribbean. If such an event occurred today, it could disable satellites, cripple power grids, and plunge modern society into temporary chaos. And yet even these tempests are but ripples on the surface of a remarkably stable star. Over billions of years, the sun has maintained a steady output of light and heat, deviating only slightly. That constancy is what matters most. Without it, Earth's climate would swing into extremes. Ecosystems would fail to adapt, and evolutionary progress would collapse again and again. Instead, our sun has been a patient guardian, flaring occasionally, yes, but never so wildly as to endanger life on Earth. It has allowed the long story of biology to continue chapter after chapter, from trilobites in ancient seas to us sitting here tonight, reflecting on its quiet gift. Every sunrise is both ordinary and miraculous. Ordinary because it has happened every single day for billions of years. Miraculous because that unbroken rhythm is precisely what allowed life to take root and flourish. The sun is not the most spectacular star in the universe, but for life for us, it is the right one. The perfect star burning with patience, holding the conditions for life steady across unimaginable spans of time. When you pause for a moment and gather together everything we've explored so far, the gentle distance from the sun, the nearly perfect circle of our orbit, the quiet neighborhood of the galaxy, the rare stability of our star, a pattern begins to emerge. None of these elements alone would be enough, but together they form a harmony so precise it almost defies belief. Think of Earth as a violin. A violin is only music when each string is tightened just enough, not too slack, not too taut. Distance is one string, orbit another stellar type, another still. Even the broader setting of the galaxy itself is part of the instrument. Any string out of tune would produce discord, but here somehow they are tuned to exact pitch. And the song that results is life. It is easy to take this for granted, to walk through a forest, feel a breeze, or watch waves roll across the shore without realizing that behind these familiar experiences is a cosmic balancing act of staggering delicacy. A nudge closer to the sun, and there would be no breeze, no forest. A more eccentric orbit, and the waves might crash against lifeless shores. A different star, and the violin might never have been strung at all. And yet here we are, living within this fragile music. Breathing, eating, dreaming, and wandering in a world whose every parameter seems improbably set. But the tuning does not end there, for Earth's harmony is not played solo. Our planet has a partner, one that hovers in the night sky, sometimes a silver crescent, sometimes a glowing disk. A companion so unusual, so influential that without it this violin of Earth might never have played the melody of life at all. That companion is the moon. And to understand just how extraordinary our world is, we need to turn to this faithful satellite, our cosmic partner in the dance of existence. Every night when the sky is clear, a familiar presence rises above the horizon. Sometimes a slender crescent, sometimes a perfect circle glowing with silver light. It is so constant, so woven into the fabric of human experience that we rarely pause to consider just how strange and improbable it really is. The moon. Our cosmic companion. At first glance, it may seem ordinary. After all, Jupiter and Saturn have dozens of moons, some larger than our own. But appearances deceive. For Earth, the moon is anything but ordinary. Its size is astonishing when considered in proportion roughly 1/4 the diameter of Earth. No other planet in the solar system has a satellite so large compared to itself. Imagine Earth as a basketball and the moon would be a tennis ball circling nearby. By contrast, Jupiter's biggest moon, Ganymede, though larger than our moon, is tiny compared to its colossal parent only about 20th its size. This unusual ratio makes the Earth-Moon system unique. It is not a planet with a mere satellite, it is more like a double world, two spheres locked together in a delicate dance. Astronomers often remark that there is nothing else quite like it in the solar system, and that uniqueness matters, because the moon is not simply a light in the sky. It is a stabilizer, a shaper, a partner in Earth's habitability. Without it, the axis of our planet might wobble chaotically, climates might swing between chaos and catastrophe, and tides, those daily rhythms that stir the oceans and shape coastliners, would be faint whispers of what they are now. The moon is not decoration. It is infrastructure, part of the deep machinery that makes Earth a home for life. Its presence is a reminder that habitability is not just about where we orbit or what kind of star warms us. It is also about the companion who pulls on us gently, endlessly, keeping our world in balance. In the stillness of night, when you gaze at its glowing face, you are not just looking at a rock, you are looking at one of the reasons you exist. If you enjoyed this moment, leave a comment with the number 1 below so I know you're still here with me. One of the most important and least obvious gifts of the moon is something you cannot see when you look up at its glowing face. It is not the light it reflects or the tides it stirs, but the steady hand it keeps on the tilt of our world. Earth spins on an axis tilted about 23.5 degrees relative to the plane of its orbit around the sun. That tilt gives us seasons, varying day lengths, and the gentle rhythm of climate that has nurtured forests, grasslands, and civilizations. But this tilt is not locked in place. Left to itself, Earth's axis would wobble like a spinning top running out of speed. Over millions of years without an anchor, it would swing chaotically, sometimes upright, sometimes leaning at dizzying angles. Computer simulations show the frightening possibilities. Without the moon's gravitational influence, Earth's axis could oscillate anywhere between 0 and 85 degrees. Imagine a world where for tens of thousands of years the poles point straight towards the sun, baking in endless daylight while the equator freezes in perpetual night. Then in another epoch the tilt shifts again, plunging the poles into eternal cold while the tropics roast under searing heat. Under such conditions, stability would be impossible. Ecosystems would collapse, oceans would alternately freeze and boil, and life as we know it, complex, delicate, dependent on predictable cycles, would never have emerged. A planet without a stabilizing moon would be a planet of extremes chaos, instead of continuity adaptation, without end survival, without progress. But because we have the moon, Earth's tilt remains confined within a narrow band. It drifts slightly over tens of thousands of years, enough to cause ice ages and warm periods, but never enough to plunge the planet into permanent catastrophe. That gentle oscillation is part of the long-term climate rhythm that shaped human evolution, pushing us out of forests across plains and into every corner of the globe. In a sense, the moon acts like a silent guardian holding Earth steady against the chaos of the cosmos. Its gravitational tug is subtle, almost tender, but the consequences are profound. The steady tilt of 23.5 degrees is not just a number in a textbook. It is the difference between chaos and stability, between a barren world and one where you can sit tonight listening, breathing, knowing seasons will come and go in their time. Without the moon, there would be no winter or summer as we know them. There would be no predictable cycles for crops, no reliable climates for civilizations to rise. Without the moon, there might be no us. The steady tilt of Earth, safeguarded by the moon, gives us something so woven into daily life that it almost disappears into the background. The seasons. Spring's renewal, summer's abundance, autumn's harvest, winter's rest. These are not just poetic cycles, but the scaffolding of survival itself. Because our axis remains near 23.5 degrees, the seasons follow a rhythm that can be trusted. Farmers have relied on this rhythm for millennia. Ancient Egyptians timed the flooding of the Nile with the heliacal rising of Sirius, a star whose appearance signaled the season to sow. In Mesoamerica, the Maya carved elaborate calendars to track solstices and equinoxes, weaving agricultural cycles into the very fabric of their spiritual lives. In China, the traditional lunar-solar calendar divided the year into 24 solar terms, guiding planting and harvesting with astonishing precision. Across cultures, the predictability of the seasons became a shared heartbeat. Stonehenge, with its massive stones aligned to solstice sunrise, was not just a monument but a calendar in stone. The pyramids, the ziggurats, the temples of the Andes, all oriented to track celestial cycles marking when to plant, when to harvest, when to give thanks. Festivals of light in midwinter, harvest feasts in autumn, celebrations of renewal in spring, these traditions scattered across continents share a common root, the dependable tilt of our planet steadied by the moon. Now imagine the alternative, a world without that stability. Summers scorching unpredictably for decades, winters dragging on for centuries. Civilizations could not plant crops, could not grow calendars, would fail. Stability is not a luxury, it is the very foundation on which human culture was built. Every loaf of bread, every cup of rice, every orchard and vineyard rests on the trust that spring will follow winter, that warmth will return, that sunlight will wax and wane in cycles as old as humanity itself. The moon's quiet tug ensures that trust. So when you look at the changing leaves of autumn, or feel the first warmth of spring after a long, cold season, you're not just witnessing weather. You're witnessing the rhythm of a tilted world held steady by its companion. That rhythm has fed us, guided us, and inspired us to tell stories, sing songs, and mark time itself. Civilization is a child of the seasons, and the seasons are a gift of the moon. Twice each day the oceans rise and fall in a rhythm as old as the earth itself. To us, tides may seem like a simple coastal curiosity, the sea creeping forward, then retreating again. But in truth, they are one of the moon's most profound gifts, a hidden engine that has shaped life on this planet from its very beginnings. The pull of the moon's gravity stirs the oceans, lifting water toward it as Earth rotates. These surges travel around the globe, filling bays, emptying shores, pushing currents through narrow straits. It is not just movement, it is mixing. Tides churn the seas, redistributing nutrients, oxygen, and heat. They prevent oceans from stagnating, ensuring that the waters remain fertile and alive. Without the tides, vast swathes of the ocean would become stagnant deserts hostile to the richness of life we know today. But the tides have done more than sustain life, they may have helped create it. Along ancient coastlines billions of years ago, shallow tide pools formed as the waters retreated. In those pools, molecules gathered, concentrated, and dried. Then, as the tide rose again, they were stirred into new combinations. Wet, dry, repeat, like a cosmic laboratory powered by the moon. Some scientists believe these tidal cycles were the crucible where simple chemistry stumbled toward biology, where the first whispers of life began to form. Even after life took hold, the tides continued to guide it. In those intertidal zones, the shifting boundaries between sea and shore creatures learned to cling, burrow, and breathe air. Crabs scuttling across sand, starfish gripping rocks, sea anemones swaying in rhythm with the water all trace their existence to this restless frontier. It was in these tidal margins that evolution rehearsed the first experiments in leaving the sea long before fins became legs. Picture an ancient coastline. The moon hangs low in a darker sky closer then than it is now, pulling tides far higher. Pools shimmer with trapped seawater alive with primitive organisms. As the waves retreat, they leave behind worlds in miniature tiny universes of struggle and possibility. Every ripple, every surge is a hand stirring the cauldron of life. And still today the moon keeps this rhythm alive. The tides feed fisheries, sculpt coasts, shape cultures. Fishermen rise and rest by their flow. Rituals are timed by their pull. Poets have written of lovers walking beaches where waves lap in endless cadence, unaware that this rhythm is the heartbeat of the moon itself. The moon does not just light our nights. It breathes in and out through the oceans, mixing sustaining and guiding life's story from the first fragile molecules to the world we know today. Every night when we see the moon suspended in the sky, it feels eternal, as if it has always been there. But the moon story begins not in stillness, but in violence in one of the most cataclysmic events our planet has ever endured. About 4.5 billion years ago, Earth itself was still young, a molten sphere battered by debris left over from the birth of the solar system. Among those wandering giants was a protoplanet about the size of Mars, which scientists have named Theia. Its path and Earth's converged, and in a moment that defies imagination, the two worlds collided. The impact was apocalyptic. Theia struck Earth at an oblique angle, releasing more energy than millions of nuclear arsenals combined. Mountains of rock vaporized instantly. Oceans of magma surged. Vast plumes of molten material were hurled into space, encircling Earth in a glowing halo of debris. From that fiery wreckage over time, gravity gathered the fragments into a single body. That body became the moon. But the story did not end with the moon's birth. The collision reshaped Earth itself in ways that proved essential for life. The impact tilted our planet's axis, setting the stage for the seasons. It spun Earth faster, shortening days to just 5 or 6 hours at first, a frenetic pace that gradually slowed to the 24-hour rhythm we know today. And deep within the planet, the violence of the collision may have stirred Earth's molten iron core, creating the geodynamo that powers our magnetic field, the invisible shield that protects us from solar winds and cosmic radiation. In other words, the moon was not simply born from catastrophe, it was part of a cosmic recalibration, tuning Earth's conditions for life. The tilt, the rotation, the magnetic shield, all are tied in one way or another to that single improbable collision. And what are the odds of such an event that a planet the right size moving at the right speed struck Earth at the exact angle? Needed not to obliterate it entirely, but to reshape it. Too direct a hit, and Earth would have been shattered. Too glancing, and no moon would have formed. It was a knife's edge of chance, and somehow we landed on it. When you look at the moon tonight, you are looking at the scar of that ancient impact, a monument to destruction that became creation. It's both a reminder of the chaos of the early solar system and a symbol of the improbable balance that followed. Out of violence came stability, out of catastrophe came the conditions for life. Without Theia, there would be no moon, no steady axis perhaps, no protective magnetic field, and no Earth as we know it. It is a sobering thought, the world we live in, the air. We breathe the stories we tell, beneath moonlight, all born from a single, unimaginable collision billions of years ago. There is a quiet miracle that plays out in our skies, one so ordinary, we forget how extraordinary it really is. The moon, though tiny compared to the sun, appears almost exactly the same size from Earth's surface. This near-perfect alignment creates one of nature's most breathtaking spectacles, the total solar eclipse. The numbers alone feel like a cosmic trick. The sun is 400 times larger than the moon, but it is also about 400 times farther away. The result is a near-perfect match in apparent size. When the moon crosses in front of the sun, its silhouette fits so precisely that it can cover the blazing solar disk, leaving only the delicate crown of plasma, the solar corona streaming out like silver fire. For a few fleeting minutes, day turns to night, the stars awaken, and humanity is reminded of its smallness beneath a choreography written across the heavens. Across cultures, eclipses have inspired awe, fear, and reverence. The ancient Chinese believed a celestial dragon devoured the sun, and people would bang drums and shout to scare it away. In Norse mythology, wolves Skuld and Hati were said to chase the sun and moon, and an eclipse was the moment when they caught their prey. For the Maya, eclipses were woven into cycles of prophecy and ritual seen as powerful omens that shaped royal decisions. Even in Greece, Thucydides described how a sudden eclipse could terrify entire armies, freezing them in place. But eclipses have also illuminated truth. In 1919, during a total solar eclipse, scientists confirmed one of the most daring predictions in modern physics. Albert Einstein's general theory of relativity suggested that gravity could bend light. The eclipse gave astronomers a chance to test it as the moon's shadow revealed stars close to the sun's edge. Their light indeed was shifted from its true position, bent by the sun's gravity. The confirmation changed science forever, and it happened only because of the perfect alignment of two celestial bodies that should, by all odds, never match so precisely. And here lies the most humbling thought: this coincidence has not always existed, nor will it last. The moon is slowly drifting away from Earth, about 3.8 centimeters each year. In the distant future, it will appear too small to fully cover the sun, and total eclipses will be no more. We just happen to live in the brief cosmic window where such beauty is possible. So when you stand in the path of an eclipse, or simply look at photographs of that ghostly corona, remember what you are witnessing: a perfect accident, a fleeting alignment, a marriage of scale and distance so exact that it seems designed for wonder. It is beauty born not of necessity, but of chance, a reminder that even in the cold mathematics of the cosmos, moments of poetry still unfold. It is easy to take the moon for granted, to think of it as a decorative lantern hung in the night sky. But imagine just for a moment a world without it. The absence would not simply dim our nights, it would transform Earth into something unrecognizable. Without the moon's gravitational pull, Earth's rotation would never have slowed to its current 24-hour rhythm. Instead, days would last only 6 to 8 hours. The planet would spin like a top, flinging the atmosphere into constant turbulence. Winds would scream at hurricane force across the globe, ripping through forests, sculpting deserts, making calm weather an impossibility. The gentle cycles of dawn and dusk, the measured pace of sunrise and sunset, all would be compressed into frantic flashes. The tilt of Earth's axis, once steadied by the moon, would become unstable, lurching wildly over millions of years. Seasons would vanish into chaos. At times, the poles might tilt straight into the sun-boiling ice caps and drowning coastlines in meltwater. In other epochs, the axis might swing away, plunging Earth into deep freezes that entombed continents in endless ice. A world without the moon would not know the patient rhythm of spring and fall, only brutal swings between extremes. The tides, too, would vanish into whispers. Without the moon, only the sun would raise the oceans, and its effect is far weaker. The vast tidal mixing that churns nutrients through the seas would be gone. The great conveyor belts of ocean circulation would stagnate. Life that depends on fertile coastlines and intertidal zones, crabs, shellfish, birds, even early land plants might never have gained a foothold. Strip away the moon, and what remains is a planet hostile to complexity. Microbes might still cling on, resilient, adaptable, thriving in volcanic vents or frozen soils. But the intricate webs of ecosystems, the long arcs of evolution that gave rise to forests, animals, and people, would have been broken before they began. Earth might still be alive, but only just. So much of what we consider normal, the length of a day, the rhythm of the seasons, the fertility of the oceans, depends on the moon's steady partnership. Without it, we would not be here to imagine its absence. The moon is not an accessory, it is an architect of habitability, a quiet partner in the dance of life. Above your head, far beyond the reach of clouds and even the highest aircraft, lies a shield you cannot see. It makes no sound, casts no shadow, and yet without it Earth would be as lifeless as Mars. This is our magnetic field, an invisible bubble that wraps the planet, deflecting dangers that pour endlessly from the sun. The sun may look serene, a golden circle in the sky, but it is in truth a raging nuclear furnace. It constantly hurls streams of charged particles into space, a torrent known as the solar wind. These particles race outward at hundreds of kilometers per second, carrying enough energy to strip atmospheres from planets' shred and sterilize surfaces. Mars and Venus show us what happens without protection. Mars once had seas and a thicker atmosphere, but when its magnetic field collapsed billions of years ago, the solar wind began stripping it bare. Today, it is a frozen desert, its atmosphere little more than a wisp. Venus, though similar in size to Earth, never developed a strong magnetic shield. Over eons, the solar wind scorched away its water, leaving behind a choking cloak of carbon dioxide and sulfuric acid. Earth, by contrast, sits inside its magnetosphere, a vast teardrop-shaped bubble, extending tens of thousands of kilometers into space. When the solar wind slams against it, the field bends and redirects the charged particles, letting them flow harmlessly around us like a river parting around a stone. Without this deflection, the solar wind would batter our atmosphere relentlessly, eroding it into nothing. And yet we rarely think of this guardian. It is silent, unseen, and constant. While you listen now, streams of solar particles are racing toward Earth, but they will not reach you. They will be caught in the folds of the magnetosphere, guided harmlessly toward the poles, where they paint the sky with auroras, shimmering curtains of green and violet, nature's luminous reminder of the shield that guards our world. The magnetic field is Earth's unseen armor, a defense that makes every breath you take possible. Without it, there would be no oceans, no air to breathe, and no living beings to tell the story. Beneath your feet, deeper than the deepest mine, farther than any drill could ever reach, something extraordinary is happening. At the heart of the Earth, nearly 3,000 kilometers below the surface, lies the secret to our invisible shield, a restless ocean of molten iron. This is Earth's outer core, a vast sphere of liquid metal heated to temperatures hotter than the surface of the sun. As this iron churns and swirls under immense pressure, it generates electrical currents, and where electricity flows, magnetism follows. In effect, Earth is a giant dynamo, a planetary generator humming without pause for billions of years. Picture it this way: every time you flick on a light switch, a generator spins somewhere, converting motion into electricity. Earth's core works on the same principle only. Instead of turbines, it is molten iron moving in colossal currents driven by the planet's internal heat and the slow cooling of its interior. The result is our global magnetic field extending outward into space like an invisible force field. But this shield is not unchanging. It drifts, flickers, and sometimes flips entirely. The magnetic poles, the points toward which compasses obediently align, are not fixed. The North Magnetic Pole has been racing across the Arctic at an accelerating pace, moving from Canada towards Siberia in recent decades. Meanwhile, the field itself is weakening slightly, a reminder that this system is alive, dynamic, and unpredictable. Even more astonishing history tells us the poles do not just wander, they reverse. Roughly every 200,000 to 300,000 years, the magnetic field flips north, becoming south, and south becoming north. The process can take millennia, during which the field weakens, leaving Earth more exposed to solar and cosmic radiation. Ancient lava flows frozen as they cooled record these reversals in their iron crystals like a geological diary of magnetic upheaval. The last full reversal happened about 780,000 years ago, meaning we are long overdue by average patterns though. Whether another is imminent remains uncertain. Imagine living through such a reversal. Compasses would point the wrong way. Auroras could appear far from the poles, glowing in skies above tropical forests. Satellites and power grids would face storms of radiation. Yet life has survived countless reversals before, even thrived, a testament to the resilience of Earth's systems. The dynamo beneath us is both a guardian and a reminder. It tells us that the shield we depend on is not permanent, but a living process powered by the restless heart of our planet. Every flicker of an aurora, every compass needle pointing north is a whisper from the core, carrying the story of a molten ocean that never sleeps. If you want to understand how vital Earth's magnetic field truly is, you need only look to our nearest neighbours, Venus and Mars. Each of them tells the story of a world without a shield, and the lessons are sobering. Take Venus. Roughly the same size and mass as Earth, born in the same region of the solar system, it might once have seemed like a twin. Yet unlike Earth, Venus never developed a strong magnetic field. Without that shield, its atmosphere has stood exposed to the full force of the solar wind. For billions of years, particles streaming from the sun have slammed against it, chipping away its water molecules and driving hydrogen into space. What remains is a suffocating cloak of carbon dioxide and sulfuric acid clouds crushing at 90 times Earth's air pressure. Venus is not a twin, but a cautionary tale, a world scorched and stripped by the sun. Now turn to Mars. Billions of years ago, it was warmer and wetter. Ancient river valleys, dry lake beds, and mineral deposits all whisper of a time when water flowed across its surface. Evidence even hints at shallow seas. But then something changed. Mars once had a magnetic field powered by a molten core like Earth's, but the field shut down about 4 billion years ago. With its shield gone, the solar wind began tearing at its atmosphere molecule by molecule. We know this not by guesswork, but by direct measurement. NASA's MAVEN spacecraft, launched in 2013, has watched the solar wind strip away gases from the Martian sky. In real time, it records oxygen ions and carbon dioxide atoms escaping into space, the slow exhalation of a dying world. Today, Mars's atmosphere is less than 1% as thick as Earth's. With no pressure to hold liquid water, rivers vanished, oceans evaporated, and the surface became the frozen desert we see now, who neighbours two fates both shaped by the absence of a magnetic shield. Venus suffocated in heat, Mars froze in thin air, and in between them Earth survives because our molten core still powers a magnetosphere that deflects the sun's fury. When you breathe in, when you watch clouds drift or feel the breeze on your face, you are living inside a rare bubble of safety. Without it, our world might look like Venus, a crushing inferno, or Mars, a barren wasteland. The shield makes the difference between a planet that merely exists and a planet that thrives. Every so often, Earth's invisible shield reveals itself in a spectacle that takes the breath away. High above the polar skies, curtains of green and violet shimmer and sway as if the heavens themselves were alive. These are the auroras, the most beautiful reminder that our planet is under constant bombardment and that it knows how to turn danger into wonder. Auroras begin with the solar wind, the endless storm of charged particles hurled outward by the sun. Most are deflected by Earth's magnetic field, flowing harmlessly around our planet like a river around a rock. But some particles slip through, funneled toward the poles along the magnetic field lines. There they collide with atoms of oxygen and nitrogen in the upper atmosphere. The collisions ignite the air. Oxygen glows green or red, nitrogen blushes purple and blue, painting the night with shifting ribbons of fire. As light flickers and curls in arcs and spirals, sometimes spreading across the entire sky, sometimes dancing in quiet whispers at the horizon. For the people who stand beneath them, the experience is otherworldly, as if the Earth itself were dreaming in colour. Across cultures, auroras have inspired stories. The Inuit of Greenland saw them as the souls of the departed playing ball with a walrus skull across the sky. The Sami of Scandinavia believed they were living spirits to be respected in silence. In medieval Europe, auroras were feared as omens of war or plague, red skies foretelling bloodshed to come. And yet today we know they are the footprints of the solar wind traced across the canvas of our protective field. What makes auroras so moving is not just their beauty, but their meaning. They are radiation lethal in space, softened by our shield and transformed into light. The same charged particles that would strip atmospheres and sterilize planets instead give us a cosmic ballet. In them we see Earth's defense not as a silent shield alone, but as an artist taking violence and turning it into wonder. So the next time you see an image of the aurora, or if you are ever lucky enough to stand under one in the frozen silence of a polar night, remember what you are truly seeing. Not just light in the sky, but the signature of survival, the beauty of a planet that knows how to guard its life. If this moment made you smile, drop a number 1 in the comments so I know you're still here with me. The story of Earth's shield is inseparable from the story of the Moon. Both were born from the same moment of catastrophe, the collision with a Mars-sized body often called Theia some 4.5 billion years ago. That impact hurled molten rock into orbit, which later coalesced into our Moon. But the consequences ran far deeper than the creation of a companion in the sky. The titanic collision also reshaped Earth itself. The violence of the impact stirred the young planet's interior like a spoon in a cauldron, mixing metals and silicates in ways that might otherwise never have occurred. The iron from Theia's core merged with Earth's, creating a molten heart rich enough in heavy elements to fuel the geodynamo, the restless churning of liquid iron that generates our magnetic field. Without that thorough mixing, some geophysicists suggest Earth might have cooled too quickly. Its dynamo could have sputtered out like Mars's, leaving us exposed to the solar wind. Without the moon's creation, we may have been left without a shield. No stable atmosphere, no oceans, no fertile ground on which complex life could take hold. The link runs deeper still. Over eons, the moon's gravitational pull has tugged at Earth, slowing its rotation from a frantic 6-hour day to the steady 24-hour rhythm we know now. That gentle braking may help regulate convection in the core, keeping the dynamo alive. In this sense, the moon is not just a stabilizer of our tilt or the maker of tides, but also a silent partner in sustaining the very magnetic cocoon that keeps us safe. Speculate for a moment on the alternative. A world with no moon. A core that never mixed a dynamo that failed. A planet stripped bare by solar winds, its oceans boiled away, its air lost to space. Perhaps microbial life could have flickered briefly, but nothing more. No forests, no animals, no humans. So when you look at the moon shining pale and distant in the night, consider the invisible bond it shares with the Earth's core. It is not only our companion, not only our stabilizer. It is in a profound sense the reason our world still breathes. Breathe in. The air that fills your lungs is so familiar, so effortless that it's easy to forget how extraordinary it is. Earth's atmosphere is not just a blanket of gases, it is a finely tuned mixture balanced with a precision that makes life possible. 78% of it is nitrogen, a quiet gas with no scent, no taste, and no immediate role in breathing. Yet nitrogen is the great diluter keeping oxygen at safe levels. It sets the stage for balance. Too little nitrogen and oxygen would overwhelm fueling fires that could ignite forests with a spark. Too much nitrogen and the chemistry of life-dead protein's amino acids would never have found the pathways that make growth possible. And yet here it is silent, invisible, sustaining. 21% is oxygen, the fiery breath of life. It is both gift and danger. With this concentration, our cells can burn fuel efficiently, powering muscles, brains, and hearts. But if the level were only a few percent higher, wildfires would rage uncontrollably, forests turning to ash in days. A few percent lower, and animals like us could not survive starved of the energy to sustain large, complex bodies. Oxygen is the razor's edge of life, dangerous in excess, deadly in scarcity, perfect at 21%. Less than 1% is argon, a noble gas that does not react, does not burn, does not interfere. At first glance it seems useless, but in truth its very stillness is valuable. Argon adds weight to the atmosphere, buffering the mixture without destabilizing it, a silent presence holding the balance steady, and then a trace carbon dioxide, just 0.04%. Such a tiny fraction, yet utterly critical. Carbon dioxide is the blanket that keeps Earth warm. Without it, the planet would plunge into ice oceans, frozen life huddling in narrow refuges. With too much, the blanket grows smothering, trapping heat, as Venus reminds us. But in its present measure, it makes seas, liquid soils, fertile forests green. It is tempting to see these numbers as arbitrary, but they are not. They are the outcome of billions of years of feedback between oceans, volcanoes, rocks, plants, and animals. The atmosphere is not static. It is alive in its own way, a conversation between geology and biology, constantly adjusting, rebalancing, breathing with the planet itself. Every inhale you take is a miracle of calibration. Nitrogen, oxygen, argon, carbon dioxide, a mixture so delicate that even small deviations could have extinguished the possibility of us. What seems ordinary is in truth impossibly rare. Oxygen is the breath of life, but it is also a fire waiting to happen. At 21% of our atmosphere, it strikes a delicate balance between abundance and restraint. It is enough to power the metabolism of animals like us who rely on oxygen to unlock energy from food, yet not so much that the world becomes a tinderbox. But Earth has not always held this balance. Travel back 300 million years to the Carboniferous period and the air was different. Oxygen then made up as much as 35% of the atmosphere. Breathing would have felt intoxicating, every breath a rush of energy. Insects grew to impossible sizes. Dragonflies with wings wider than hawks, millipedes, as long as cars, their bodies fueled by the abundance of oxygen that diffused easily into their tissues. Yet such richness came with danger. Forests burned more fiercely then. A lightning strike could set entire regions ablaze, fires spreading uncontrollably in the oxygen-rich world. Life flourished, but it also lived in constant risk of flame. Over time, Earth corrected itself. The oxygen levels fell, first slowly, then settling near the 21% we know today. This balance has persisted for tens of millions of years, long enough for mammals, forests, and eventually humans to thrive. Fires still burn, but they do not consume the world. Animals still breathe, but without combusting from within. The atmosphere's balance is not an accident. It is regulated by cycles, plants, and algae, releasing oxygen during photosynthesis, animals and microbes consuming it in respiration, wildfires and volcanoes adjusting it further. A planetary negotiation endlessly recalibrated. At 21%, oxygen is just right. Enough for thought, muscle, and memory. Enough for forests, oceans, and skies to teem with life. It is quite literally the breath of stability, a balance struck over eons, and one we depend on with every inhale. If oxygen is the spark of life, then nitrogen is its quiet backbone. Invisible, odorless, making up nearly 78% of the air, nitrogen often feels like empty filler. But without it, life would have no framework. Every protein in your body, every strand of DNA, every neuron firing in your brain is built on nitrogen's bonds. It is the thread that ties life together at the molecular level. Yet most of this nitrogen floating free in the air is inaccessible. Its molecules are bound so tightly, triple-bonded atoms locked together, that animals and plants cannot break them apart. To us, atmospheric nitrogen is like a banquet behind glass, abundant but untouchable. So Earth devised a cycle. Enter the nitrogen-fixing bacteria. In soils, in the roots of legumes, in the oceans, drifting plankton and microbes split nitrogen's stubborn bonds, turning it into ammonia, nitrates and nitrites, forms that plants can use. Through them, nitrogen enters the food chain from soil to roots, from leaves to grazers, from prey to predator. Eventually, when life ends, other microbes return it to the air and the cycle begins anew. Sometimes the sky lends a hand. Lightning cracks open nitrogen molecules in a flash of heat, forging them into compounds that rain down to feed the soil. A storm in this sense is not only thunder and rain, but a kind of atmospheric fertilizer refreshing the ground for the next season's growth. In the modern age, humans have learned to mimic this process. The Haber-Bosch process, developed in the early 20th century, uses immense pressure and heat to break nitrogen apart, creating ammonia for fertilizers. This discovery transformed agriculture, feeding billions who might otherwise have starved. Yet it also tipped the balance, releasing excess nitrogen into rivers and seas, fueling algal blooms and dead zones. Once again, we see how delicate the cycle is, and how easily it can be disturbed. Nitrogen is both silent and essential. It steadies our air, diluting oxygen to safe levels. It builds the molecules of life-threading atoms into proteins and genes. It cycles endlessly from sky to soil, from root to leaf, from mouth to breath, a quiet backbone sustaining every living thing. Now we come to the quietest ingredient in our air, present in only the faintest whisper, carbon dioxide, a mere 0.04% of the atmosphere. At first glance, it seems negligible, almost an afterthought compared to nitrogen and oxygen. Yet this trace gas is one of the planet's most powerful regulators, the subtle hand that keeps Earth's climate in balance. Without enough carbon dioxide, Earth would be locked in a deep freeze. The oceans would harden under ice, forests would wither, and deserts of frost would spread across the continents. But with too much, the opposite occurs. The air becomes a suffocating greenhouse. Just look at Venus, where carbon dioxide makes up more than 95% of the atmosphere. Their heat is trapped so effectively that the surface bakes at 460 degrees Celsius, hot enough to melt lead. Here on Earth, that 0.04% has kept conditions within a narrow band, warm enough for oceans, stable enough for forests, gentle enough for life. For billions of years, natural systems have acted like a thermostat. Volcanoes release carbon dioxide, oceans absorb it. Rocks weather it out of the air. Forests and plankton breathe it in and release it again. A vast interlocking cycle keeps that sliver of atmosphere steady, like a tightrope walked across geological time. But in the past 2 centuries, humans have tilted the balance. By burning coal, oil and gas, we have returned ancient carbon to the sky at a pace far beyond what Earth's natural systems can reabsorb. Carbon dioxide has climbed from 0.028% in pre-industrial times to over 0.042% today. A small shift in number, but immense in effect. It is enough to raise global temperatures, melt ice sheets, alter ocean currents, and destabilize the climate patterns on which civilization depends. This is the double truth of carbon dioxide. It is both tiny and titanic. Tiny in its proportion, titanic in its influence. The air you exhale with every breath is part of the same cycle that governs glaciers, storms, and seas. And while Earth has survived great swings of carbon dioxide in the past human society, our crops, our cities, our coastlines is built on the fragile stability of the last 10,000 years. Carbon dioxide is a reminder that even the smallest measures matter. A few molecules more, a few molecules less, and the fate of the entire planet shifts. Above your head, far higher than clouds, lies a fragile shield. It's not visible, not tangible, and yet without it, the surface of Earth would be scorched bare. This is the ozone layer, a thin band within the stratosphere where oxygen molecules bind into 3O3 instead of the familiar O2. These ozone molecules perform an extraordinary service. They absorb the most dangerous wavelengths of the sun's ultraviolet radiation, the kind that shreds DNA and burns skin, the kind that would sterilize the land if it fell unfiltered. With ozone, life flourishes in forests and fields. Without it, only the ocean depths might have offered refuge. And yet the ozone layer is thin. If you gathered all of it at sea level, it would form a sheet no thicker than a few millimeters, a fragile veil guarding an entire planet. In the late 20th century, when human chemicals began eroding this shield, scientists watched with alarm as a hole widened above Antarctica. Only swift global action banning chlorofluorocarbons began to mend it, a reminder of how delicate our blanket is and how quickly it can fray. But the atmosphere protects in another way, one less obvious but just as vital pressure. At sea level, air presses down with the weight of one atmosphere about 14.7 pounds per square inch. That pressure holds liquid water in place. Too low, and water would boil away into space even at cool temperatures. Too high, and life would struggle under a crushing weight, its chemistry skewed. Our pressure is just right, the middle ground between chaos and sterility. Together, ozone and pressure make Earth's air into a perfect invisible blanket. It warms without smothering shields, without suffocating. It lets oceans stay liquid, forests stay green, and bodies yours, mine, and every creature's thrive under the constant rain of sunlight. We cannot see this blanket, but we live wrapped in it every second of our lives. A shield so thin it could be torn so precise that a small shift could doom us, and yet here it is enduring through billions of years. Long before humans, long before mammals, even before forests, Earth faced a puzzle that could have ended life before it began. Our sun, 4 billion years ago, was fainter than it is today, shining with only about 70% of its current strength. By rights, our planet should have been a frozen world locked in ice, its oceans sealed under miles of frost. And yet evidence from ancient rocks shows rivers flowing, oceans, liquid microbes thriving. This is known as the faint young sun paradox. The solution lies in Earth's natural thermostat. Greenhouse gases like carbon dioxide and methane once cloaked the young planet in a thicker, warmer blanket than today. Volcanoes spewed CO2 into the skies. Early microbial life pumped methane into the air. These gases trapped enough heat to offset the weak young sun, keeping the oceans liquid and life alive. Over billions of years, as the sun brightened, Earth adjusted. The concentrations of greenhouse gases fell. Rocks drew down CO2 through weathering. Photosynthetic life consumed carbon dioxide and released oxygen. Each change fed into another, creating a network of negative feedbacks that kept temperatures within a habitable range. When the world grew too warm, chemical weathering sped up, pulling CO2 from the air. When the world cooled, ice slowed those reactions, allowing greenhouse gases to build again. The thermostat was never perfect. There were snowball Earths when glaciers crept toward the equator. There were hothouse periods when tropical forests stretched into polar latitudes. But always the system pulled itself back from the edge, stabilizing over millions of years. That resilience is why we are here to tell the story at all. Imagine a home whose heater adjusts automatically without anyone touching the dial, keeping the rooms within a narrow comfort zone as the fuel supply slowly changes. Earth has been living in such a home for billions of years, thanks to the interplay of geology, atmosphere, and life itself. The paradox of the faint young sun is in truth not a paradox at all, but evidence of a self-regulating planet, a world that learns to hold itself steady amid chaos. The Earth is not passive, it listens to the sun, to the oceans, to the breath of forests and volcanoes, and then answers back. Its climate is not a fixed point, but a conversation across time, balanced through a network of geological feedback loops. Consider weathering. When carbon dioxide rises in the atmosphere, the planet warms and rainfall increases. More water running across rocks means more chemical reactions. The rock's especially silicates draw down carbon dioxide, locking it away as minerals. Over millions of years, the atmosphere cools again. It is a slow hand on the thermostat, moving in rhythms far longer than human lifetimes, but steady and sure. Then there are volcanoes. Their eruption seems sudden violent fire bursting from the ground, but in the grand cycle they are part of the balancing act. Volcanoes return buried carbon to the air, replenishing greenhouse gases when they grow too scarce. Without their steady breath, Earth might have cooled beyond recovery long ago, and the oceans, those vast blue lungs of the planet. They inhale carbon when it is abundant, dissolving it into water, and storing it in shells and sediments. They exhale it again when conditions shift, a slow rhythm that stabilizes the air above. Currents carry warmth from equator to pole, preventing extremes and spreading balance across latitudes. Earth's history is written in ice and fire, in feedbacks that have carried the planet through crises. During the Snowball Earth episode hundreds of millions of years ago, glaciers advanced nearly to the equator. For a time the world seemed on the brink of eternal ice. But volcanoes kept erupting beneath the glaciers, releasing carbon dioxide that built year by year, century by century, until the greenhouse blanket grew thick enough to thaw the planet. Oceans cracked open, life spread again, and Earth returned to balance. At other times, the pendulum swung the other way. Massive volcanic outpourings like the Siberian traps 250 million years ago flooded the air with greenhouse gases. The climate surged into heat, species fell in mass extinction. Yet even then, over millions of years, weathering and ocean absorption drew the excess down. Balance once more was restored. These loops, rock, fire, water, and air, are the planet's immune system. They do not prevent illness, but they heal it. They allow Earth to drift toward ice, toward fire, but not to stay there forever. Always eventually it returns to the narrow band where liquid water flows and life persists. Resilience is written into the planet itself. And though the balance is never perfect, never static, it is enduring. We are children of that resilience, born only because Earth has always somehow found its way back. Earth's story is not one of uninterrupted calm. It is punctuated by catastrophes, moments when life nearly vanished, when the balance tipped so far that the world seemed beyond saving, and yet again and again Earth has recovered. The most devastating chapter came 252 million years ago at the end of the Permian period. In what scientists call the Great Dying, over 90% of marine species and 2/3 of land life disappeared. The trigger was fire from below colossal volcanic eruptions in Siberia that released unimaginable amounts of carbon dioxide. The climate spiraled into a greenhouse so intense that oceans grew stagnant, skies dimmed with ash, and ecosystems collapsed. For millions of years the world seemed broken. But even this was not the end. Weathering of newly exposed rocks drew carbon back out of the air. The carbon cycle reset. Slowly, painfully, life crept back, the ancestors of mammals among its survivors. Go further back and we find Earth locked in ice during the Snowball Earth events of the Proterozoic. Imagine glaciers stretching from poles to equator seas, frozen to depths of hundreds of meters. It seemed impossible for life to endure. Yet beneath the ice, in hydrothermal vents and thin pockets of liquid water, microbes clung on. Meanwhile, volcanoes erupted relentlessly, adding carbon dioxide to the air. With no liquid oceans to draw it down, the gas built up until greenhouse warmth shattered the global freeze. Glaciers melted, seas reopened, and the planet surged back to life with a vigor that would eventually lead to complex organisms. Even the famous asteroid impact that ended the reign of the dinosaurs 6 million years ago fits into this rhythm of extinction and recovery. The blast threw Earth into a sudden winter, smothering forests and starving ecosystems. Yet within a few 100,000 years, a blink in geological time, mammals began to thrive, filling the empty niches, setting the stage for humanity's eventual rise. The pattern is haunting and hopeful. Earth's thermostat and feedback loops do not prevent disaster, but they ensure survival. The planet is like a tightrope walker, swaying wildly at times, even stumbling, but always regaining balance. Mass extinctions erase worlds, yet they also clear paths for new beginnings. We are heirs to this cycle. Every forest, every bird, every human heartbeat exists because the Earth has always recovered. It is a reminder of fragility, yes, but also of resilience. Life endures because the planet, however battered, always finds its way back to equilibrium. Beneath your feet the ground feels solid, eternal. Yet in truth Earth's surface is a restless skin, forever created, destroyed and renewed. This is the realm of plate tectonics, the planet's great geological machine and one of the deepest reasons our world is alive. At mid-ocean ridges, molten rock wells upward from the mantle, hardening into new crust. Imagine a seam that never heals constantly, pushing the seafloor apart like a conveyor belt. Thousands of kilometers away at subduction zones, that same crust dives back into the depths, melting once more into the mantle's fiery heart. It is a cycle of creation and destruction measured not in seconds but in centimeters per year, the pace of your fingernails growing. Yet across millions of years it remakes continents, mountains, and oceans. This endless recycling has consequences far beyond geology. It helps regulate the carbon cycle, drawing down carbon dioxide when mountains weather, then releasing it again through volcanoes. It keeps Earth's thermostat steady over eons. It recycles nutrients phosphorus, nitrogen, sulfur, and trace metals, returning them to the surface to fuel ecosystems. And it sculpts the landscapes in which life diversifies from jagged mountain ranges to fertile valleys. Now compare Earth with its neighbours. Mars, once volcanically alive, lost its internal heat. Its crust froze into stillness, tectonics ceased, and with them the long-term recycling of atmosphere and nutrients. Today it is a barren desert, its once flowing rivers preserved only as scars. Venus, by contrast, seems locked under a single stagnant shell. Heat builds beneath until it vents, catastrophically resurfacing vast regions in violent floods of lava. Without the steady release of plate tectonics, Venus suffers extremes that make it a furnace of choking carbon dioxide and sulfuric acid clouds. Earth is the only planet we know with tectonic plates that grind, collide, and slide, and it may be the only reason complex life has endured here. Our world is not static stone, but a breathing surface, a geological engine that keeps the air breathable, the oceans liquid, and the land fertile. The ground may feel still beneath you, but in truth you are standing on a moving raft, part of a vast planetary machine that never rests. Every mountain range, every ocean trench, every trembling earthquake is more than geology. It is part of the hidden system that sustains life itself. Plate tectonics is not just a restless reshaping of continents. It is a lifeline linking the deep earth with the biosphere above. When mountains rise as the Himalayas did when India collided with Asia, or as the Andes still do along South America's western edge, they begin a quiet work that shapes the entire planet. Fresh rock is exposed to wind and rain. Over centuries, water dissolves minerals, drawing carbon dioxide from the air in chemical weathering. The carbon ends up in rivers, then oceans locked into sediments and shells. Later, when tectonic plates carry those sediments downward into the mantle, volcanoes breathe the carbon back into the sky. This push and pull is Earth's long-term CO2 regulator, a planetary thermostat that has kept temperatures habitable across billions of years. The Himalayas towering above the world are not only majestic, they are climate engineers. Their weathering has helped cool Earth over the past 50 million years, balancing the warming effect of a brightening sun. The Andes, meanwhile, create vast rain shadows and unique ecosystems. Amazonian rivers on one side, dry deserts like the Atacama on the other. The biology of South America, from orchids to llamas, is written into the uplift of those mountains. Plate tectonics is also a nutrient pump. When volcanoes erupt, they scatter phosphorus, iron, and sulfur across land and sea, elements essential for life. Without this recycling, soils would eventually be depleted, oceans would starve, and ecosystems would wither. Instead, Earth is endlessly renewed. Each eruption, each uplift feeds the cycles of fertility that allow forests to regrow and oceans to teem with life. It's humbling to realize that the vegetables on a dinner plate, the breath of oxygen in your lungs, even the rhythm of ice ages and warm periods, all are tied to the slow grinding of tectonic plates beneath us. What seems like destruction, earthquakes, eruptions, mountains thrust skyward, is in truth creation, the continual weaving of conditions that allow life to flourish. The story of life is not written only in DNA. It is also carved in stone and soil, shaped by the restless hand of plate tectonics. For as the continents drift, collide, and rise, they sculpt landscapes that become the stage on which evolution plays out. Think of a single mountain range. Its peaks are cloaked in snowfields, where only the hardiest mosses survive. Below lie alpine meadows buzzing with insects and grazed by hardy animals. Further down, forests spread across slopes, rivers rush through valleys, and plains stretch outward, supporting vast herds. From a single uplift, countless habitats emerge, and each habitat becomes a crucible for unique life. This is why tectonically active regions often harbour extraordinary biodiversity. More niches mean more opportunities for adaptation for new species to flourish. Consider the Great Rift Valley of Africa. Born from the slow pulling apart of tectonic plates, it gave rise not only to rich savannas teeming with life, but also to the cradles where early humans evolved. Or the Andes, whose uplift created both high-altitude ecosystems filled with llamas and condors and lowland rivers that helped form the vast Amazon basin, a rainforest whose diversity is unmatched on Earth. Tectonics does more than sculpt nature. It also shapes civilization. Rivers born in mountains, the Nile, the Ganges, the Yangtze, became arteries of human culture carrying water, fertile silt and trade. Valleys carved by tectonic uplift provided shelter and farmland. Even spiritual traditions often look upward. Mountains revered as sacred places, rivers honored as divine lifelines. Humanity has always been, in a sense, a child of tectonic landscapes. Without shifting plates, Earth would be geologically quiet, flat, uniform, monotonous. Evolution would be slower, biodiversity sparse, and civilizations perhaps never born. Instead, the restless movement beneath our feet gave us mountains to climb, rivers to follow, fertile soils to sow, and ecosystems in which life, including ours, could experiment, fail, and triumph. We owe not only our survival, but our stories to the mountains and valleys created by Earth's geological heartbeat. Far beyond Mars, more than 600 million kilometers from the Sun, there hangs a world so immense it could swallow 1,000 Earths. This is Jupiter, the largest planet in our solar system, a giant whose sheer mass has shaped the fate of every world around it. And for us, it has been more than a neighbor. It has been a guardian. Jupiter is 2.5 times more massive than all the other planets combined. Its gravity is overwhelming, a cosmic net that catches or deflects stray wanderers, asteroids, and comets that might otherwise slam into Earth with catastrophic force. Its orbit, nearly circular and stable, sits at just the right distance to shield the inner solar system without tearing it apart. It is as if the architecture of our planetary family were built around this silent protector. We saw its shield in action in 1994 when the world held its breath as fragments of the comet Shoemaker-Levy 9 hurtled into Jupiter. One by one, they struck the planet's atmosphere, exploding with energies greater than all the nuclear weapons on Earth combined. For days, Earth-based telescopes and the Hubble Space Telescope recorded dark scars spreading across Jupiter's swirling clouds, bruises from impacts that would have been extinction-level events had they struck us. But they did not. Jupiter took the blows, and this was not a one-time act. For billions of years, Jupiter has been sweeping the solar system clean. Objects tugged from the Kuiper belt, fragments from the asteroid belt, icy comets falling inward from the Oort cloud, many never reach us because they are captured, deflected, or consumed by the giant. Astronomers sometimes call Jupiter the solar system's vacuum cleaner, but perhaps a better name is shield bearer. Without it, the early Earth might have been bombarded so relentlessly that life could never have taken hold. Imagine for a moment a night sky without Jupiter. A solar system where asteroids strike not every tens of millions of years, but every few thousand. Where oceans barely have time to stabilize before another cosmic hammer falls. Where evolution is not a long story of increasing complexity, but a cycle of endless restarts. In such a world, you and I would not be here. Jupiter, the giant of storms and stripes, has been both a spectacle and a savior. Its great red spot, a storm larger than Earth itself, reminds us of its ferocity. But its enduring role is quite or unseen, the steady guardian that has time and again stepped between us and the void. It is one thing to say Jupiter is massive, but its true wonder lies in how perfectly calibrated it is for its role as protector. If it were only a little different in mass, in distance, in orbit, the entire story of Earth might have unfolded another way or not at all. Jupiter's mass is vast, yet not too vast. Were it smaller, its gravity would not be strong enough to intercept many comets and asteroids. Were it larger, it might have disrupted the orbits of Earth and the other inner planets, tugging them into instability, or even ejecting them from the solar system. Instead, it sits at a cosmic sweet spot, heavy enough to guard, gentle enough not to destroy. Its orbit matters too. Jupiter travels in a nearly circular path, 5 astronomical units from the Sun. Had it been closer, its gravitational pull might have flung Earth into chaos. Had it been farther, it would have been too distant to protect us effectively. Its placement is like a watchman standing at the perfect distance, close enough to guard the door, far enough not to trample the threshold. And Jupiter does not act alone. It is partnered with Saturn, the second giant, whose orbit resonates with Jupiter's in a kind of cosmic harmony. Every time Jupiter orbits the Sun twice, Saturn completes almost exactly 5 circuits. This resonance stabilizes both giants, preventing wild gravitational swings. Together, they form a gravitational shield wall, sweeping comets and asteroids away from the inner solar system like shepherds guiding a flock. This arrangement, Jupiter's mass, Saturn's resonance, their distance and stability, is not common in the exoplanetary systems we've discovered. Many stars harbour hot Jupiter's giants that migrated inward, scouring away any chance of rocky life-bearing planets. Others lack such giants, entirely leaving small planets exposed to endless bombardment. Ours is different. Our solar system is built like an architecture of safety with Jupiter as the cornerstone. Think of the elegance of this arrangement. The sun warms us, the Earth holds us, the moon steadies us, and far away Jupiter and Saturn guard us. It is a layered design, a cosmic choreography that has kept Earth's surface stable long enough for oceans to form, forests to grow, and civilizations to rise. When you glance up and see Jupiter as a bright star in the night sky, you're not only looking at the largest planet in our system, you're looking at the silent partner that has for billions of years kept the path clear for life to endure. Every living thing on Earth, from the smallest cell to the tallest tree, moves to a rhythm older than memory, the turning of our planet. 24 hours, that is the length of a day, the time it takes for Earth to spin once on its axis. It is so familiar that we rarely question it. Yet this rotation, neither too fast nor too slow, is one of the most finely tuned features of our world. If Earth spun much faster, days would be short, just a handful of hours. The surface would be lashed by constant hurricane-force winds whipped up by the rapid heating and cooling of land and sea. Organisms would struggle to adapt to an environment where night and day changed so quickly, where rest and activity blurred into chaos. If Earth spun much slower, days might stretch to weeks or months. Half the planet would bake under unending sunlight while the other half froze in endless darkness. The atmosphere would convulse with colossal storms, and only narrow bands of twilight might remain habitable. But Earth's 24-hour cycle is a middle path, a tempo steady enough to allow warmth to spread but swift enough to prevent extremes. This balance has given life a drumbeat to grow by. Plants open and close their leaves with the rising and setting of the sun. Animals stir, hunt, migrate, and sleep according to the same rhythm. And inside your own cells there are tiny molecular clocks, circadian rhythms that anticipate dawn and dusk, aligning your biology with the planet's spin. This rhythm was not always so. When Earth first formed, a day may have been only 5 or 6 hours long. Over billions of years, the gravitational pull of the moon has acted like a brake, steadily slowing our spin until it lengthened into the cycle we know today. And it will not stop. Millions of years from now, days will stretch longer still. But for the epoch in which complex life arose and humans eventually appeared, Earth's rotation has been perfectly timed for stability and growth. So each sunrise, each nightfall is not just a passage of hours. It is the beat of the planet's heart, the tempo of the story of life. You too are part of that rhythm, your breath and sleep entwined with the turning of the world beneath your feet. Our world leans. At a glance, Earth seems upright as it spins around the sun, but in truth its axis is tilted about 23.5 degrees off vertical. That gentle tilt is the reason we know spring blossoms, summer heat, autumn harvests and winter snows. It is the reason no year ever feels quite the same as the last. Without that tilt there would be no seasons. The equator would swelter under unchanging heat, the poles would lie locked in eternal ice, and vast regions would lack the variety that drives both ecology and culture. With too much tilt, on the other hand, the world would lurch between extremes, searing summers followed by crushing winters, the kind of instability that makes complex life fragile. But at 23.5 degrees, Earth strikes a balance. It offers change without chaos, rhythm without ruin. This cycle has shaped agriculture, the cornerstone of civilization. Farmers learned to sow with spring rains, reap in summer's bounty, and store for winter's scarcity. Entire calendars were carved from this pattern: solstices and equinoxes, marked with stone circles at Stonehenge pyramids aligned to the sun. In Egypt and Mesoamerica, rituals and festivals timed to celestial shifts. The predictability of seasons gave humans the confidence to settle, to build villages, then cities, then civilizations. Nature too has been sculpted by the tilt. Birds migrate thousands of miles, guided by the return of warmth. Bears fatten in autumn to endure winter's sleep. Forests shed their leaves only to burst forth anew with spring's light. The dance of seasonality is an evolutionary engine pushing life to adapt to time reproduction, to find strategies for lean months and abundant ones alike. So the tilt of Earth is not just geometry. It is a gift of cycles of planting and harvest, of birth and rest of ceremony and story. It is the balance between sameness and surprise, giving us a world not frozen in monotony but alive with rhythm. Each season whispers to us of time's passage, reminding us that life itself is a sequence of changes, forever turning, forever renewing. One turn of the earth gives us a day, but a full journey around the sun, 365 days, gives us a year, the longer rhythm that shapes all life on this planet. It is the cycle that stretches beyond the daily pulse of sunrise and sunset, weaving together the pattern of the seasons. Why 365? It is the consequence of Earth's distance from the Sun, about 150 million kilometers, and the Sun's mass which sets the speed of our orbit. Too far and our year would stretch into centuries, too close and it would shrink to months. But for Earth, this measure of time has settled into a span just right for ecosystems to thrive. Compare us with our neighbours. Mercury racing around the Sun completes its orbit in only 88 Earth days, barely a season long. Life there would have no time to adapt before conditions changed again. Neptune, on the other hand, drifts through a year that lasts 165 Earth years. Imagine winters that outlive generations, summers that entire species might not survive to see end. Only on Earth does a year last the right length, not too fleeting, not too vast for plants to grow, animals to migrate, and ecosystems to reset with dependable rhythm. This yearly cycle is the foundation of ecological timing. Trees know when to bloom, releasing pollen only as spring days lengthen. Salmon return upriver in synchronization with melting snows. Insects hatch when flowers open, ensuring both find survival in the other's timing. Even human cultures, from ancient farmers to modern cities, plan by this orbit. Harvest festivals, school calendars, New Year celebrations all echo the turning Earth around its star. Without this dependable circuit of 3 years, today's ecosystems would fracture. If the year were too short, seasons would flash by in chaos, never giving crops time to ripen or animals time to prepare. If it were too long, extremes would linger, pushing life toward collapse. Instead, Earth's year is precisely the measure required for stability and renewal, long enough for patience, short enough for change. Each time our planet completes its journey around the Sun, it is not just a return to where we began. It is another loop in the spiral of history, another opportunity for life to endure, to adapt and to grow. Take a moment to imagine the simplest of molecules, 2 atoms of hydrogen bound to 1 atom of oxygen. H2O, so small, so unassuming that you could sketch it on the back of an envelope. And yet this humble shape is nothing less than the miracle substance of our world, the liquid thread on which the tapestry of life is woven. Water is everywhere in the cosmos. We find it frozen on comets, locked in the icy crusts of Europa, and Enceladus, hidden as vapor in distant nebulae. It is one of the most common compounds in the universe, but in almost all those places it exists only as ice or gas. Here on Earth, it flows in rivers, gathers in oceans, and falls from the sky as rain. That liquid state, so fragile and so rare, is the stage on which biology plays. Its properties are extraordinary. Water is called the universal solvent because it can dissolve more substances than any other liquid. Inside your body, this allows nutrients, hormones, and waste to be carried from cell to cell, organ to organ. In the ancient oceans, it allowed the first molecules of life to mingle, react, and eventually give rise to the spark of biology. Without water's solvent power, chemistry would remain inert, unable to build complexity. Water also has a remarkable heat capacity. It absorbs and releases vast amounts of energy without changing temperature quickly. This means our oceans act like planetary thermostats, buffering the extremes of climate, keeping Earth's temperatures stable enough for life. During the day, seas soak up the sun's warmth. At night, they release it slowly, ensuring the planet never veers into wild swings of heat and cold. And then there is the strange grace of hydrogen bonding. Water molecules cling to each other with weak electrical ties, a property that gives water its surface, tension, its ability to rise through roots into leaves, and its peculiar behavior of expanding when it freezes. Because of this, ice floats instead of sinking. Lakes freeze from the top down, leaving liquid water beneath the ice where fish and plants survive through winter. If water behaved like most substances, oceans would freeze solid from the bottom up, entombing life forever. It is no exaggeration to say that water seems tailor-made for life. Not too volatile, not too inert, not just a backdrop for biology, but a participant in every step. In your cells at this very moment, countless reactions are occurring only because water holds them in suspension, stabilizing, transporting, and shaping the molecules of existence. so common and yet so rare in its most precious form. A world may be covered in ice or swaddled in steam, but to hold seas and rivers of liquid water is a privilege almost unimaginable in the cold, dry vastness of space. That Earth has it and has kept it for billions of years is nothing less than miraculous. In most of nature's chemistry, cold means contraction. Molecules draw closer together as they lose energy and solids sink beneath their liquid forms. But water, ever the rebel among substances, defies this rule. When it freezes, it expands. Its molecules lock into a crystalline lattice that is less dense than the liquid state, and so ice floats. At first glance, this quirk might seem trivial, a curiosity of physics, yet it is one of the most consequential properties in all of existence. Imagine a world where ice behaved like most substances, sinking as it solidified. Lakes, rivers, and seas would freeze from the bottom upward, layer upon layer of ice piling down until whole oceans became solid blocks. In such a world, there would be no thaw in spring, no refuge for fish in winter waters, no cycles of liquid stability. The oceans would have become tombs, trapping the planet in an icy stasis. Life, if it ever began, would likely have been extinguished before it could evolve beyond microbes. But because ice floats, Earth's waters remain alive. When winter comes, a thin shield of frozen surface insulates the liquid depths below, protecting ecosystems until warmth returns. Beneath frozen ponds, fish glide slowly through the cold, plants release oxygen in dim light, and food chains continue in muted rhythm. In the oceans, floating polar ice caps stabilize climate and currents, shaping the balance of life across the globe. This single inversion of expectation expansion instead of contraction made Earth's seas a cradle of continuity. It preserved liquid sanctuaries through ice ages, allowed evolution to march forward unbroken, and ensured that water would serve not just as a medium for life's chemistry, but as a shelter for its survival. It is a reminder that sometimes the strangest behaviors of nature carry the greatest consequences. In every snowflake drifting past your window, in every frozen pond shimmering under winter light, there is a quiet miracle. Ice floats, and so we live. Look closely at the architecture of life, and you will find water woven into its very blueprints. The molecules that define us, DNA, proteins, enzymes, and membranes, all rely on water, not simply as a background, but as an active participant in their existence. DNA, the double helix of heredity, only holds its elegant spiral because of water. Hydrogen bonds link its strands, while water molecules surround and stabilize the structure, protecting its fragile code. Without water, DNA would unravel into chaos, the script of life dissolved into meaningless fragments. Proteins too, the molecular machines of every cell, fold into precise shapes because of water. Some amino acids seek its embrace, others shun it, and this dance of attraction and repulsion guides each protein into its unique form. A change in folding, a misstep in that watery choreography, and the protein fails in its task. Water is not an observer, it is the silent conductor of biology's symphony. Even the membranes of cells, the thin skins that divide inside from outside, are sculpted by water. Fatty molecules arrange themselves to shield their water-fearing tails and expose their water-loving heads, creating barriers that both protect and communicate. Without this watery tension, the cell itself could not exist. But water's role in life extends beyond the molecular to the cultural and spiritual. Across civilizations, it has been revered as the giver of life. In ancient Mesopotamia, rivers like the Tigris and Euphrates were worshipped as divine lifelines. In Egypt, the Nile's floods were celebrated as gifts from the gods, renewing soil and sustaining civilization. In Hindu tradition, the Ganges is sacred, a living goddess whose waters purify body and soul. Baptismal waters in Christianity symbolize rebirth, cleansing the old self and welcoming the new. Again and again, humanity has recognized something deeper in water, not just chemistry but mystery. Its flowing, purifying, sustaining nature has made it a universal metaphor for renewal, transformation, and life itself. So when you lift a glass of water to your lips, you hold not only molecules that stabilize DNA, fold proteins, and sustain cells, you hold the same essence that cultures have called sacred, that rivers have carried for eons, that oceans have guarded since the dawn of time. Water is the medium of chemistry, the memory of evolution, and the symbol of our shared fragility. It is quite simply life. Step back now and let us look at the design as a whole. Piece by piece, we have examined Earth's conditions, the orbit so nearly circular, the moon stabilizing our tilt, the magnetic field shielding us from the sun, the atmosphere tuned to delicate proportion, the thermostat balancing warmth and cold, the tectonic plates recycling life's nutrients. Jupiter standing guard in the outer darkness, the steady rhythms of days and seasons, and water itself, miraculous, abundant and liquid. Each is remarkable on its own, but taken together they form an improbable pattern that feels almost too precise to be chance. Consider if our orbit varied a little more, climate would swing into chaos. If the moon had never formed Earth's axis would wobble, seasons would vanish, and life might never stabilize. Without the magnetosphere, the atmosphere would have been stripped, leaving us bare to radiation. Without tectonics, carbon would not cycle. Climates would not recover, nutrients would not replenish. Without Jupiter, bombardment from comets might have sterilized our world countless times over. And without water, not frozen, not vaporized, but liquid life's chemistry could never have begun. Each of these conditions could be dismissed as coincidence. But when you assemble them into a mosaic, the improbability compounds. It is like rolling dice again and again, and every time the numbers align to spell out life. Earth is not merely a lucky planet, it is a symphony of luck upon luck, calibrations stacked upon calibrations, balance upon balance. Scientists speak of the fine-tuning problem with humility. No one claims these alignments prove design, nor do they insist they are mere flukes. Instead, they point to the awe these patterns inspire, the recognition that we exist in a universe where so many unlikely things happen to fall into place. In the silence between explanations lies wonder. It is here in this improbable weave of orbital mechanics, geology, chemistry, and cosmic architecture that we find ourselves a fragile species with the ability to reflect on our own unlikeliness. That reflection is itself part of the miracle, for in contemplating the pattern we become part of it, a conscious thread woven into the improbable fabric of life. Imagine for a moment that you could drift far beyond the Milky Way, out where the spiral arms blur into mist, where galaxies float like lanterns in the void. From that vantage you would see countless suns scattered across the darkness, each orbited by its family of worlds. Gas giants swaddled in storms, rocky planets scorched by heat, frozen wastelands where the air itself lies trapped as ice. Everywhere the cosmos hums with energy and motion, and yet almost everywhere it is hostile, silent, lifeless. And then among the billions, a flicker. A small pale blue dot circling an unremarkable star in an unremarkable arm of an ordinary galaxy. At first glance, nothing special, but look closer and you see clouds swirling, oceans glimmering, continents rising and eroding. You see forests breathing, rivers carving valleys, creatures stirring. A world that is not only alive but finely balanced, as though tuned to a pitch that allows the melody of life to be played. How do we explain this improbable harmony? 3 perspectives have long shaped the conversation. The first is chance framed by the anthropic principle. Out of uncountable possibilities, some planet had to land the cosmic dice roll, and we are here because this one did. We should not be surprised to find Earth suited to life, for if it were not, we would not be here to notice. It is circular logic, perhaps, but humbling in its simplicity. The second is hidden laws. Perhaps there are principles of physics and chemistry not yet known to us, rules that make habitable worlds far more likely than they appear. Maybe the universe is not a lottery at all, but a garden where life springs naturally whenever conditions allow. What looks improbable from our perspective might on a deeper level be inevitable. The third is deeper purpose. Not necessarily divine in the traditional sense, but a suggestion that something beyond our current understanding, consciousness, or meaning shapes the cosmos in ways we cannot yet name. That life is not an accident of matter, but an expression of something woven into the fabric of reality itself. Whichever perspective one leans toward, the conclusion is the same. We live in a world of staggering unlikeliness. Every breath we take is supported by balances so fragile that even small shifts could erase us. To recognize this is to feel awe, and awe in turn invites gratitude and responsibility. For if Earth is this rare, this finely tuned, then it is not merely a place to live, it is a trust. Our orbit, our seasons, our shield of air and magnetism, our oceans and rivers, they are not guaranteed forever. They are gifts passed through time, entrusted to us by billions of years of chance, law, or purpose. So tonight, as you close your eyes, hold that vision of the pale blue dot in your mind. A world adrift in vast blackness, fragile yet flourishing, improbable yet alive. Remember that you are part of its story, a consciousness capable of wonder. And perhaps that more than anything else is what it all means, that in a universe of silence and fire, life found a way to look up, to ask questions, to feel gratitude, and to dream. Thanks for being here. Hit that subscribe button and join us for the next chapters full of history and discovery,